Hi there, welcome to another video from Hegarty Maths. It's Mr. Hegarty here, our second video on graph transformations of the form f brackets x plus or subtract a. Let's start with what we did in the previous video. In the previous video we had a graph or a function and we considered the transformation of f of x add a or f of x subtract a, and we were able to draw the graphs for them. Do you remember what the transformations were on the original function? Pause the video and have a think. Well, you should remember that in the first case it was a translation by 0a, which meant that the whole function moved vertically up by a units, if a is positive that is, and in the second case it was a translation by 0 negative a, so the whole graph moved down vertically by a units where a was positive. Now in this particular video we're going to consider things like this: f of brackets x add a and f of brackets x subtract a. Now here there is a big difference here. We are adding the a to the x value here, okay, and we are subtracting the a from the x value here. Here we were adding a to f of x, which is y. Here we were subtracting a from f of x, which is the same thing as y. So we're going to get totally different transformations. So let's go and use a bit of graphing software to see what's going on. So pull up the graphing software. I've got our function that we like using, f of x is x squared. I've also drawn what we did in the last video, f of x add a, and we know what happens there. If I just press play, when you are adding a, okay, to f of x, you are doing a vertical translation. If you're adding a positive number, you're moving the graph up a units. If you're subtracting a number, you're moving the graph down by a units. Now what I'm going to do is, for this video, they're not the ones we're interested in. We're interested in f of x add a, where you're adding a to the x value inside the bracket. So I'm going to start with a, b, 0, so they're the same. Now let's have a look what happens. Say I work out f of brackets x add 3. Watch. The graph has moved 3 units to the left. f of x add 7. The graph has moved 7 units to the left. f of x add 10. The graph has moved 10 units in the x direction horizontally to the left. Now what if I subtract a number? Say I subtract 5. I'm working out f of brackets x subtract 5. The graph's moved 5 units to the right this time. And you can see if I just keep playing, here I'm working out f of x add 4.9. The graph has moved 4.9 units to the left. And I think you can clearly see here what's going on. Here I am subtracting 4. So I'm working out f of x subtract 4, and the graph has moved 4 units to the right. So when I am adding inside the brackets to the x value, we are definitely talking about a translation across, so horizontally, not vertically, and it's kind of doing the opposite to what you think. If you're working out, let's say here, f of x add a, it's moved the whole graph 6 units to the left. And the other way around, if you're working out f of x subtract a, it moves the graph 6 units to the right. So let's try and formalize what's going on here. So here we can say that we do have a translation, and it's going to be by. Now it is in the horizontal direction, but it's the opposite way to what you think. When you add a, you're moving the graph left by a units, so it'd be negative a 0, i.e. horizontally, and this time we're going not right but left by a, and in this case it's a translation again. It is in the horizontal direction, but when you're taking away a, you actually move to the right by positive a units, so translation by a 0, and again we would write that means horizontally right this time by a units. Okay, and there's a summary for that. So before we launch into some questions, let's try and have a think, why is this happening? Because it feels maybe potentially a bit weird. So let's start off with our function being x squared. We put a number in and we square it. We know the graph looks like that, and I've drawn the table of values between -3 and +3. Now we know from the work we've just done on the graphing software that f of brackets x add 2, i.e. I take x add 2 and I square it, that's my function. That shifts this function to the left by 2 units. And the question is, why on earth is that the case? And I suppose the way to see it is to maybe look at particular values. Now let's think, in this original function, in the function case f of x, when I got the y number to be 0, I had to have x is 0. Now when do I get the y number to be 0 here? Let's have a look. I get the y number to be 0 when x is negative 2. So what here, where I had 0, 0, here I'm going to have negative 2, 0. It's almost like this function here is seeing the y numbers that are happening earlier. This saw the y number 0 when x was 0. This sees the y number 0 when x is negative 2. It's seeing those y numbers 2 units earlier. And we can take that with other examples as well. We can say to ourselves, right, let's pick, for example, this one here, 9. When does it see 9? This function sees 9 when x is 1. This function sees 9 when x was 3. So f of x add 2 sees the 9 two places earlier than that. So it's drawing the graph out 2 spaces before that, 2 units earlier. That's kind of why the graph is moving 2 units to the left. That's just a nice way of thinking why on earth that's happening. Anyway, that is what's happening. The summary is as follows. If you have an original function f of x add a, if a is a positive number, that's a translation by negative a, 0. It's moving to the left by a. And if you're working out f of brackets x subtract a, it's a translation again, but this time by positive a, 0. So it's in the x direction. Let's try some questions at last. Pause the video, have a go here. So we're given the function f of x in the diagram. We're asked to draw f of brackets x add 1. We should know straight away that that's a translation, and it's in the x direction, and it's by negative 1, 0. It moves the graph left by 1 unit. This point would therefore move left to here. This point would move left to here. This point would move left to here. This point would move left to here. We've probably got enough points to try and join the dots here. Let's give it a go. And that's a rough outline of our graph f of x add 1, which has been moved 1 unit to the left like that. Let's try another question. Pause the video, have a go. Now we're given the graph of f of x. We're asked to draw the graph of f of x subtract 1. That's a translation in the x direction, and it's by positive 1, 0. So we're going to move the whole graph to the right by 1. This point would move here. This point would move here. This point would move here, this point here would move here, and that's a fairly decent outline. Let's try and join the dots now. And there you go, that is our attempt at the graph f of x subtract 1, which has been a movement to the right by 1 unit. Let's have a go at another one. Pause the video, have a go. Well, in this one we're given the graph f of x. We're told it has a minimum at 3, negative 4, which is down here, 3, negative 4, and we're asked to state the coordinates of the turning points of the following graphs. F of x subtract 9. Now you should know that's a translation in the x direction by, now it's the opposite to what you think, it's going to be positive 9, 0. So all the x values are moving by 9 units in the positive direction. So this here, this will move from 3, negative 4 to 12, negative 4. What about this one? Well, this is a translation by negative 5, 0. So all the x coordinates are moving to the left by 5. So this here will move to the left by 5. It will be at negative 2, negative 4. And we're done. Let's have a go at another one. Pause the video, have a think. Well, we're told the curve with equation f of x is transformed so that 0, 3, this must be this point here, 0, 3, moves to the point negative 2, 3, which must be this point here. State in terms of f of x the transform function. Well, it seems that the function has moved to the left by 2 units. So remember, if we're moving to the left, okay, it must be f of x add 2. Remember that add 2 makes us move to the left by 2 units. So that is the transform function. And the very last one, pause the video, have a think. Well, this time it gives us f of x and it says it is transformed so its minimum point, -2, -1, which must be this point here, moves to the point 3, -1. So moves to this point here, which is going to be 3, -1. It says state in terms of f of x the transform function. This point seems to have moved 5 units in that direction, so this curve here must be the graph f of x take away 5. Remember, subtracting 5 makes you move the whole graph 5 units to the right. And that's it for this particular video. Thanks loads for watching.